All right, now let's talk about something called the vertical line test. So when determining if something is a function, it can sometimes be tricky because you want to think about all possibilities. Is any x value going to give me two different y values? So sometimes a nice way to look at it is to look at the graph. And we have the vertical line test, which will tell us if a graph is the graph of a function or not. So not every graph in the rectangular coordinate system is the graph of a function. The definition of a function specifies that no value of x can be paired with two or more different values of y. So if you plug in x and you get two different answers or more for the same x, then you do not have a function. And we can use the vertical line test to help us determine if we have a function or not. So the vertical line test says the following. If any vertical line intersects a graph more than one point, the graph does not define f as a function. So it's not a function. Okay. So if any vertical line intersects the graph at more than one point. Now, these are vertical lines that you're going to mentally draw, or you can physically draw them if you like. So I usually like to use an actual pen or a pencil. So what you do is you just draw some vertical lines through a graph. And again, you can do this mentally or physically. And if it hits that graph more than once, so each line, one individual line, if it hits that graph more than once, it's not a function. So this hits twice. So it's not a function. And I just have to have one vertical line that hits twice. Doesn't have to occur all the time. If it happens one time, then that's it. If I try to do this line, right? If I hit, so again, I'm looking at the blue line. Every time I draw my line, it only hits one time. So this is a function. Same thing here. Any vertical line that I try to draw through, I only ever hit that graph one time. So it is a function. And then here, if I just find one vertical line that fails, right? So that one hits twice. So it's not a function. Now, the reason why this works, so let me show you kind of just a quick example here. Let's say I had a nice circle. And maybe this is the point. This is 2, 0, -1, -2, 1, 2, -2. Okay. So let's consider drawing a vertical line right here. So we hit twice, right? So notice what's happening. This point here has an x value of 0 and a y value of 2. And this point has an x value of 0 and a y value of -2. So when you hit twice on a vertical line, you're showing that one x value goes to two different y values. And that's why it's not a function. Okay. So that's why the vertical line test works. It's because specifically on that vertical line, you have that same x value at two different y values. So it's failing that test, so it's not a function. All right, let's do one more example here. So obtaining information from graphs. And this is example 8 in your text. It says, too late for that flu shot now. It's only 8 a.m. and you're feeling lousy. Fascinated by the way the algebra models the world, your author is projecting a bit here. You construct a graph showing your body temperature from 8 a.m. through 3 p.m. You decide to let X represent the number of hours after 8 a.m. and Y represent your body temperature at that time. And your graph is shown to the left. The symbol on the y-axis shows that there is a break in values between 0 and 98 degrees. See right there? That's the first tick mark on your y-axis represents a temperature of 98. So they are showing you that you have a break in the y-axis here because for this student, their temperature is always above 98 degrees. So it didn't make sense to have a whole bunch of blank space on that graph. So that's why you have that jump in scale. And let's answer the question. So what is your temperature at 8 a.m.? Now you just want to be careful here. X is the number of hours, it says, after 8 a.m., right? After 8 a.m. So when X is equal to 0, this is at 8 a.m. When X is equal to 1, this would be 9 a.m. When X equals 2, this is 10 a.m. and so on. So that's what that means there. So what is your temperature at 8 a.m.? Well, 8 a.m. is when X is 0. So looking on my graph here, when X is 0, my temperature is 101 degrees. During which period of time is your temperature decreasing? So decreasing means you have this going down direction. We read the graph left to right. So it's going down from left to right. And you can see that our graph is going down from here to here, right? You can see this kind of decreasing piece. So we're decreasing from 8 a.m. until, now it ends at X equals 3. So X equals 3 would be 11 a.m. Estimate your minimum temperature during the time period. How many hours after 8 a.m. does it occur at what time? So our minimum temperature, so where is it the lowest during this time period? Clearly it's the lowest right here. So if I kind of move over, it looks like it's maybe 98.5 degrees, maybe 98.6 degrees, something like that, would be our estimate here. So I'm going to say let's see, estimate your minimum temperature. I'm going to say our minimum temperature is about 98, probably 0.6 degrees. And it occurs when 3 hours after 8 a.m., which is 11 a.m., right? So our minimum is right here. It's at the 3-hour mark, which correlates to 11 a.m. And if I go over there, it looks like it's probably 98.6, which is, the average temperature we usually talk about. During which time period is your temperature increasing? Well, we can see we're increasing or going up. So increasing means you're going up from here to here, right? So the graph is going up. So it is increasing from, let's see, that's 11 a.m. When X equals 4, we're at noon, so 12 p.m. And when X equals 5, we're at 1 p.m. So we're increasing from 11 a.m. until 1 p.m. Part of the graph is shown as a horizontal line segment. So that's this part right here. What does this mean about your temperature and when does this occur? So, oh, sorry, you can't see that. So let me just go back through here. Sorry, I thought you could see this. This is where we're decreasing, right? This is where we're increasing, going up. And then now we see that we are horizontal right here. So what does it mean to be horizontal? Well, it means that the Y value is not changing. So that at this point, our temperature is not changing. So what does this mean about your temperature? So it means our temperature is not changing. It's not going up. It's not going down. And when does this occur? Well, it occurs 5 to 7 hours after 8 a.m. So let's see, at 6, we're at 2 p.m. And at 7, we're at 3 p.m. So it occurs from the 5 to the 7. So from 1 p.m. to 3 p.m. Okay. And then our last question, let me try to zoom out a little bit more. Explain why the graph defines y as a function of x. So why is this a function? Well, first of all, just looking at the graph, it passes the vertical line test. So if you come down here and you try to draw all these vertical lines throughout your graph, they're all going to just hit one time. You're not going to have a vertical line that hits twice. So it is a function. We say that it passes the vertical line test. So we have that piece here. But if you also think about what's going on, if we're talking about individual time checks, So let's say you check your temperature just one time at 8 a.m., 9 a.m., 10 a.m., 11, 12, and so on. Well, you would have just one answer there, right? If you check your temperature one time, I'm thinking about like a forehead thermometer here with my kids. If I check their temperature at 8 a.m., I'm just going to get one answer, right? I'm not going to get two different answers, theoretically, assuming you have a good thermometer and it's accurate and stuff like that. So you should just have one output each time you check your temperature. So it does make sense that this is a function.